Okay, good evening. Yeah, good evening. Wow, we enter into this live and someone says, "Can you do grade six?" Are you kidding me? Hi, man. Don't be funny. Bokamuso, what in the world, bro? Grade six. Try and find another platforms there. I actually don't do grade six. Grade six, you can do grade six. I don't do, unfortunately. So if you followed me with the hope that I would do grade six at some point, just unfollow. I don't do grade six. Okay, guys. I can go. Tebucho, I went live today for grade 10. I'm going to do grade 10 tomorrow. Yes, tomorrow morning. Yeah. Grade 10 tomorrow, 7 a.m. Yeah, let's gun for 7 a.m. tomorrow. Okay. So this is for grade 12. Hello, grade 12s. I hope you're well. This is me coming live for you. It's for you, grade 12s. And today what we are going to be doing is we are going to be jumping into grade 12 functions, inverse functions. Okay, so if you guys are asking me what it's inverse functions, vandaag we're starting that. Okay, I think I've made a decision that let us rather start inverse functions because it seems like many of the grade 11s are still hung up, or they're still not clear about functions as far as their grade 11 was concerned. Okay, I will at a later time devote some more airtime to functions that have to do with grade 11. But for now, let us do grade 12, guys. Yeah, grade 12 is crying for us, begging for attention. So let's get straight down to sweet business. Okay, just a sec. I just want to double tap on the screen. Yes, Tando. Tomorrow as well, grade 11. Grade 11 will do it. Let's plan for, yeah, because grade 10 will do at 7. Yeah, let's do grade 10 at 7 a.m. and then let's do grade 11 at 8:30. So grade 11 at 8:30 tomorrow morning, grade 10 at 7 a.m. Let's do it like that. Okay, grade 12s, I'm just going to have to say it over and over again that I'm doing grade 12, but for now, let me just take down the sticker because it's in the way. All right, so guys, we are going to look at grade 12 functions, specifically inverse functions. This word inverse, it's not an old word. It's not a new word for you guys. You should know the word inverse. Okay, for instance, if I ask you what is the inverse of plus, okay, the word inverse simply means the opposite. Okay, so the inverse of positive is, let's see in the comment section if you guys can tell me what is the inverse operation of positive. Luyanda is like, is this the first lesson for grade 11, grade 12? It's the first lesson for grade 12 as far as inverse functions are concerned. Okay, thank you, Maeo. I was like, I corner negative. That's the inverse. The inverse of positive is negative. The inverse of multiply. The inverse of multiply. Thank you, guys. Division. Okay, so with all intents and purposes, we call the opposites of divide and multiply the multiplicative inverse. Okay, multiplicative inverse. Whereas the inverse of plus and minus we refer to as the additive inverse. So this word inverse is not a new word, as I am saying to you. Okay, so we are going to look at functions. Now, functions, what is a function? So let's now formally look at the definition of the word function. A function f is defined. What is it defined as? It's defined as a relationship. Okay, I know you guys have relationships yourself. There's healthy relationships and there's bad relationships. Okay, healthy and unhealthy relationships. Hopefully, as young people, you are having healthy relationships, the right kind of relationships. Because there's a multitude of relationships we can talk about. We can talk about family relationships. We can talk about friendship relationships. There's many types of relationships. So here specifically, we're not talking about those kinds, but a function f is defined as a relationship. This relationship is between what? It is between the values where each input value. Now, the word input is also not a new word. Input value. Usually, guys, when we talk about input value, which variable do you guys associate the input value with? If I say input, which variable, letter of the alphabet usually, in equations that you have done, what variable do you associate the input with? Input value is associated with which variable? I think. What do you think? Thank you, Maeo. You're thinking well. All right. You're thinking very, very well. You're thinking so well, Maeo. It's amazing how well you are thinking. Right? Keep on thinking the way you are thinking. So we talk about the association of input. We usually talk about the x value. And the x value has everything to do with the values on the x-axis. If we are talking about the Cartesian plane, the values on the x-axis, those are the x values, the input values. So it says here that a function f is defined as a relationship between values where each input value maps. Okay, there's another word, maps. It maps to one output value. In other words, each input value produces one unique output value. So every input will produce a unique output. Output value, guys, which variable do we associate the output value with? Thank you, Luyanda. You are thinking very well. Why? All right. Thank you very much. Thank you. Okay, so that is the definition of a function. So once again, a function f is defined as a relationship between values where each input value, meaning x, maps onto one unique output value. Okay, so for every input we have a unique output. For every input we have a unique output. Then here, for it to be called a function, furthermore, we have what we call as a one-to-one function. One-to-one. Guys, one-to-one. Okay, we have what we call as a one-to-one function. What is a one-to-one function? This is where there is a single y value for a particular x value. This is what I call, guys, monogamy. Monogamy. Right? When there are two people that unite in holy matrimony, they get married, there is one unique person for the other one. And it's only that one with that one only. Right? This is where there is a single y value for a particular x value. This is where there is a single male man for one particular female marriage, holy matrimony. This is where there is a single y value for a particular x value. All right. So every x value has a particular output value that produces a point, and those many points produce what we call a function. Okay, so here are some examples. The type of one-to-one functions that we have seen from grades 10, 11, and 12 are the following. A linear function, which is also called a straight line graph, is a typical example graphically of a one-to-one function. Why do we call a linear function a one-to-one function? It is because for every x value, meaning for every x value you have, there is a single but unique y value that must be there, which produces a point there, 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 and all of these points lie on this line. But for every point, there is a unique x value and there is a unique y value that have a relationship which then produce a point, and these many points on this line produce this function, which we call a linear function. There is no place in this function where maybe one x value will produce many y values. No. In other words, one male seems to have two females. Or two females has, one female has many males. No. That kind of relationship for a one-to-one. So I hope you guys get the point. One-to-one, one y value with one x value. That's the relationship. So a linear function is an example of a one-to-one function. Okay. A exponential function, whatever the shape is another example of a one-to-one function. Because on a exponential function, every x value produces a unique y value, as do every y value produce a unique x value. Right? Everywhere along this function, there are points where x and y are unique. All right? Okay, I hope that makes sense. It's another one-to-one, this one. The last function, which is a one-to-one, is the function that we call as the hyperbola function. Sometimes, so actually I just wanted to say, it's a hyperbola function. So the hyperbola function also exhibits the same quality, that if for instance the hyperbola function has an arm in the first quadrant and another arm in the third quadrant, this obviously we know this is where a is greater than 0. So when that is the case, when the exponential function, the hyperbola function is in the first and the third quadrant, Likewise, along this function, every x value will produce a unique y value on this arm and obviously on this arm. Okay? Yeah. And then, of course, we know that there's the asymptotes where the function is not defined, which is also fine. For instance, for this function, the function is not defined where y is equal to 0, and it's definitely not defined where x is equal to 2, which means at this point, the function does not exist. The line x is equal to 2, which is a vertical line, the function does not exist. And then the line y is equal to 0, which is the horizontal line, the function does not exist. But it is one-to-one at every other point where the function exists. So guys, all functions can either be, according to the definition, be one-to-one functions. Now you may notice that we did not speak about the parabola when we were talking about a one-to-one function. We spoke about a linear function, a exponential function, and a hyperbola function being what? One-to-one. For every single y value on those functions, there is a particular unique x value. All right. The second type of function that we talk about is not the one-to-one function, but the second type of function is what we call a many-to-one. What do we call it? A many to what? To one. Okay. A many to one. Many to one. Many to one. Very important. Right? So let's just look, for instance, at the one-to-one. That means for every single x value, there is a unique y value. Now, what is a many to one? Okay. What is a many to one? So let us take it one step at a time. A function cannot have more than one y value. I repeat, a function cannot, will not, and must not have more than one what? Y value to each x value. I repeat again, a function cannot have more than one y value to each x value. So note this, what it says here. In actual fact, this here is speaking about a one-to-many. Let me repeat again. A function cannot have more than one y value to each x value. All right. So we can't have one x value to many y values. That is not a function. A one-to-many is not a function. One x value to many y values. Problem. Problem, problem, problem. Not a function. Rather, a many-to-one, though, on the other hand, a many-to-one, this is a function that can have more than one x value for a particular y value. If we have a situation like that, we call that function a many-to-one. I repeat, a many-to-one, this is a function that can have more than one x value for a particular y value. So I'm going to obviously look at the parabola and explain why we say a parabola is a function given the definition of many to one. I repeat, this is a function that can have more than one what? X value for a particular y value. We call that a many to one. A many to one is a function, but a one to many is not a function. So let us look at a parabola. Let's take for an example. On the x-axis, on what we call the x-axis, the y value on the x-axis, guys, what is the y value on the x-axis? Let me ask you guys. You guys will tell me. And if you can tell me, then I know that you guys at least have, on the x-axis, what is the value of y? Everywhere on the x-axis, what is the value of y, guys? Thank you, Tumi. Thank you, Maeu. Thank you, Precious. Thank you, Sipo. Skybird, CBC. Wow, what a name. Skybird. We're going to be flying tonight, aren't we, hey? So, yes, the value, the equation of the x-axis, guys, is y is equal to 0. So, everywhere on the x-axis, here, y is 0. Here, y is 0. Here, everywhere, y is 0. So, everywhere on the x-axis, y is 0. So, can we agree that on the x-axis, there is a unique y value? It is the same everywhere. There is a particular unique y value, which is y, which is 0, everywhere on the x-axis. But please note that for the function, the parabola, here, the value of x, let's say it was negative, let's say negative 2, just for argument's sake. And let's say here it was positive 5. This negative 2 and positive 5 are the values of what, guys? What values are these for? This negative 2 and positive 5. This negative 2 and positive 5, what values are those for? For which variable? Is it the x value or is it the y value? This negative 2 and 5 are for who exactly? Okay, Unati, thank you so much. So, negative 2 and 5 are the values of x on the x-axis. Negative 2 and 5. So, what do you then see from the parabola? Many x values produce one y value. I repeat, many x values, negative 2 and 5, are producing the one y value, which is what? 0. All right. So that is a typical many x values to one unique y value. All right. Are we together here, guys? Many to one. Many x values. The many means minus 2 and 5. Minus 2 and 5 mean more than one value of x. Okay, that's many. Then on the line where these two values lie, the one unique value that they produce is y, which is 0. In this point, y is 0. At this point, y is 0. So we call a parabola a many to one function. We call a parabola a what? A many to one. It is not a one to one. Okay. On this horizontal line, for instance, there can be a unique y value. Let's say, for instance, here y is equal to 3. That y, which is 3, which is unique, has how many x values? many x values. There's an x value that produces 3 here, which is positive, and there's an x value this side, which is negative, which also produces 3. Many to 1. Guys, I want to move on. I want to get an indication from you in the comment section. Are we understanding the concept of many to 1 on the basis of my explanation of the parabola? If not, you must indicate in the comment section. If you do, then we can proceed forward. Because guys, in grade 12, this is where the definition of a function needs to be understood by you once and for all. A function f is defined as a relationship between the values where each input, which is x, maps on or produces one output, which is y. We call that, for it to be called a function, it can either be a one-to-one. In other words, one input value produces a unique output value where there is a single y value for a particular x value. We see that very well with a straight line function. This is not a many-to-one. It is not a many-to-one. This one can only be a one-to-one because it is a straight line. Every unique x value produces a unique y value. Exponential function. This is an exponential function. It is a typical example of a one-to-one. Every y value is produced by a unique x value. Hyperbola. This is a typical one-to-one because every x value has a unique y value. The second type of function is not one-to-one, but it is many-to-one. What is a many-to-one? This is a function that can have more than one x value for a particular single y value. We call that a many-to-one. So we have, in essence, only two manifestations of a function. It can either be one-to-one, as a linear, exponential, and hyperbola function show us that that can be the case, or it can be a many-to-one, as a parabola indicates to us. But a one-to-many is not a function. Okay, guys, that is the basic foundation that we need as we start off functions. One-to-one, key function. Straight line, linear function. Exponential, one-to-one. Hyperbola, one-to-one. Second type of function, many-to-one. In other words, many x values for a particular y value. Parabola shows us the qualities of a many-to-one, my beloved grade 12s. So I hope we are clear there. So now, moving right along, we have what we call two tests that we can always undergo. One that is called the vertical line. Guys, a vertical line, Moski line, so. Okay, from top to bottom, give vertical line. This is a vertical line. So we have what we call a vertical line test. What is that vertical line test used for? It is used to test if a graph is a function. What is the vertical line test used for? It's used to test if a graph is a function. So if a vertical line, let's say that line is a line parallel to what? To the y-axis. So if we can place a vertical line, okay, parallel to the y-axis, There's the y-axis. Obviously, the y-axis is vertical, so we have a corresponding vertical line that we can move left and right. So this thing is saying if a vertical line parallel to the y-axis touches the graph more than once at any point. I repeat, if a vertical line parallel to the y-axis touches the graph more than once at any point, then we say that the graph is not a function. If a vertical line parallel to the y-axis touches the graph more than once at any point, then the graph is not a function. To do this, we can either use a ruler or let's say a pen. I'm going to show you with even a pen. You just hold a ruler, a pen, and if the ruler touches more than once for a single x value anywhere on the graph, we say the graph is not a function. That is what the vertical line test is. So let me just show you what we mean, guys. This is a toothpick. This is a toothpick. I'm sure you guys have an idea now what I was eating earlier on. Toothpicks are used to do something, especially when you are fighting there in the teeth. So if we have this, let's say this is the ruler, it's a vertical line. So what we do is we are going to hold this vertical line. It's going to be parallel to the y-axis. What we do is we move this line. You can see, guys, that the graph is being touched always at one point. Okay, when I'm talking about the graph, I'm talking about this line, this straight line that has an increasing gradient. So when I pass through my line, it's always touching one point all the way through. So this is a way that you can test if a particular function, is it a function or not. This one is obviously a function. This exponential function as well, when you move it, you can see it's touching everywhere. It's touching one point. At every vertical point, it's touching only one point. It does not cut the graph twice. It's only cutting the graph once as we move it. Okay. Same thing with the hyperbola function. You move it, touching the graph only once, cutting once vertically. Even with the parabola, guys, you move it along this vertical line from the beginning till the end, it's always cutting once. So this thing is saying if a vertical line parallel to the y-axis touches your graph more than once, which we did not see with those graphs, then if it did touch more than once, we would say that that particular graph is not a function. Okay, so I'm just here on the side. Just want to show you something. Grade 12s, I just want to show you something. Let's say we had a parabola like this. Then what you want to do with this parabola, whatever this shape is, let's say it's a particular graph. Okay, we want to check if this graph is a function. If I take a vertical, this toothpick of mine, which is vertical, and I move it, guys, notice something. You see, when I'm placing this particular vertical line on the graph, is it cutting the graph more than once? That's my question to you. At this point where I'm at, is the line cutting the graph more than once? Okay, precious, it definitely is, right? Yeah. We move it again. You see, everywhere this graph is being cut more than once. It's being cut twice, to be specific. So because it is being cut twice, we then say that in this particular situation, whatever this here that is drawn is, we say that this is not a function. All right, it is not a function because, can I tell you something? Let's say at this point, what can we say? All right, most we know on a vertical line, the x values are the same. All right. So the honest reality is that, let's say this is where this toothpick is cutting. Here, x is 2, let's say, for instance. We know along this vertical line, x will be equal to 2. That is one unique x value. But for every x value, what's happening to y? There's a y value here, maybe let's say it's 3, and there's a y value here, and let's say it's -1. So that means we have a situation of x1 x value to what? Y. How many y values at this x value? At this one x value, how many y values are we seeing? We are seeing many x value. So this is a typical 1 is too many. Do you remember what we said earlier on about a 1 is too many? A function cannot have more than one y value to each x value. I repeat, a function cannot have more than one y value to each x value. That is not a function. A what? A one to many. A one to many is not a function. So I hope now you are actually internalizing the definition of what a function is. A function, guys, can only be two things. Either one to one unique x value produced by one y value, or it can be many to one. Many x values for one y value. Okay, so hopefully, guys, we are, it's coming. So the vertical line test helps us to confirm if something is a function or not. The what? The vertical line test. Right. So guys, what I've just done with you now is I've explained the definition of a function, because in grade 12, that is the key thing about grade 12, is that the definition of a function should be explained and known. And learners must know what a function is, what a one-to-one is, and what a many-to-one is, because those are the two manifestations of a function. Now, as it relates specifically to the functions you have done, that is why we call this a linear function. We call this an exponential function. We call this a hyperbola function, because 1, 2, 3 are typical examples of one-to-one. The definition, single y value for a particular x value. Married couple, one-to-one. Then many-to-one, parabola. That's why a parabola is referred to as a function or a quadratic function. It is a manifestation of a many-to-one. And these are the functions you've learned in grade 11. So now there is foundational understanding of why you say those particular functions are functions as per the definition, guys. Okay. All right. Hopefully we are breathing. Sense is being made. Understanding is arriving. Clarity of mind is there. Functions are clear to us. If there is a question, the English will fumble us, and the fumble will English you. Okay, the fumble will English you as well. Just as the English will fumble, the fumble will English you as well, right? Yeah, obvious. Okay, now guys, let us move on. We are now going to enter into this world of what we call inverse. So for starters, we are just going to look at what a inverse graph is and how to determine a inverse graph. So for now, guys, I just want you to get into the rhythm of being able to find what a inverse graph is. listen to me and listen to me well. An inverse graph, to determine or to get the inverse of a function, we simply do the following, guys, and it's a matter of really sticking to the method. Unfortunately, my son, I don't do grade 7, okay, but yeah, next year when you do grade 8, you can follow me in the other alternative Maths is a Game platform, and me and you will meet in 2027. So 2026 is not my year for you and me, but 2027, it is my year with you. And you must tell your parents very soon, very early, that you met this guy, you saw him, he's explaining grade 12. You want to do well in grade 8, 9, 10, 11, 12. You want to be my buddy. I will take you under my wing. We'll fly together, and you can do wonders in maths from grade 8 to 12. Okay. So unfortunately, me and you, we can't be one for now. So time is everything. You have to wait. Okay. So inverse graph. To determine the inverse of a function, we simply do the following. Guys, hopefully you can do this. Are you guys all able to swap in a given equation x and y? Do we know what it means to swap? We swap, we exchange, in other words, exchange something for something else. If, let's say, for instance, you guys, I'm sure some of you are still wearing your weave. The girls, I can imagine, some of you in your schools, you can't wear weave when you go to school. So some of you still have your weaves on, whilst I don't have one. So let's say if we decide to swap, it's like me grabbing that weave off your head, because Mos, you have put glue, Mos, on that forehead of yours so that the weave can stay. So me, I just snatch that weave, I put it on my head, then I shave my head, I give you my hair. That is swapping, guys. That is a nice example of swapping the weave for the hair for the weave. Okay, so we are going to swap x and y in the defining equation. Whatever equation we've been given, or the function we've been given, we will swap x and y. And then number 2, we make y the subject of that particular equation. Now, when you talk about making something the subject, what grade did we do literal equations, making something the subject of something? You remember in grade 10? Okay. Grade 10, guys, that's where we actually did literal equations, making x or y the subject of the formula. So we do that, we swap x and y, and then we make y the subject of the formula. That's what we did in grade 10. So grade 10 is being incorporated here in this particular aspect of finding the inverse of a function. So here are the guiding principles when you do this. If your function, let's say, was written in the form, and guys, that functions are written in, when we say f of x, we call this functional notation. I know it's big English, but it just means when you have a function being written f of x, this is just notation that we call functional notation. We know most that f of x stands for what, guys? What does f of x stand for? G of x, h of x, t of x, l of x, m of x, Sisbulele of x, Williams of x, Sekhametsi of x, Tumi of x, Borwangi of x, Tumi of x, Kwazi of x. What does all of that of x mean? Yes, in the comment section, you guys are 100%. The of x means y. So if the function is written in the form of f of x is equal, now what you must do, you must rewrite that particular function to be in the form of y Hey, in the place of f of x, you guys, what you've just commented in the comment section is what we basically need to change that functional notation to be in the form y is equal to. All right. Then in your final answer, because you know, obviously you will rewrite in that form, okay? You'll do the swapping, you make y the subject, then after that, your final answer for that inverse must be written in the form. Now here's some notation for you. The inverse of f, the what? The inverse. This is an exponent, guys. It's a negative one. This exponent that is a negative one is what basically inverse means. The inverse of the function f. Please, please, please. F of to the power negative 1 of x is equal to your final answer. The final answer in functional notation, inverse of f. Okay. So when you see this notation, it simply means that it's the inverse. Okay. All right. I hope you guys are following. Now let us proceed and look at some examples. And then after the examples, let it burn, let it burn, let it burn. Okay. Or we can just say, happy birthday, Beyonce. I guess, whatever one you guys feel is the best, in the situation. I think situations warrant different reactions and approaches. So you must decide which one you think is relevant currently, just align ourselves to what you guys think is most whatever it is. Okay. Almighty then. Let us proceed. Okay, I think Barney is liking the happy Beyonce one. Okay, let's go. Okay, so now example 1, they want the inverse of f if f of x is equal to 3x plus 2. Thank you, Sekhamedze, for the friendship necklace. I didn't see that. Sorry, my bad. Not watching, not looking there. Thank you so much there for the rosa as well. Okay, guys, so the inverse of f, if f of x is equal to 3x plus 2. So let us follow what we've just learned. First step, they said we must swap, or if the function is written in the form of f of x, our objective is to rewrite in the form y is equal to. So let us rewrite. F of x at the moment, we write y is equal to 3x plus 2. Has the rewrite happened? Yes, successfully. All right. So I would be very happy with whoever did this. I'm like, good job, buddy. Like, you are so amazing. Like, I mean, really now, hi? Second step, swap x and y. Do what? Swap x and y. As part of trying to find the inverse, we need to swap the x and the y. So this is like the weave, this is like Tumi's weave, and the Mets is the game host's hair. So I shave my hair, I then put it together, hand it over to Tumi. Tumi takes my hair, I take her weave, and snatch it off her head and I put it on. So this is what's happening now. Tumi's weave, my hair. The swapping has happened successfully. Swapping has happened successfully. Okay, so y is equal to swap x and y. Okay, then step 3, literal equations from grade 10. Make y the subject of the formula or the equation. So currently what we can see is there 3y plus 2 is equal to x. Okay, so what we do is we use take the plus 2, we transpose, or in other words, what is the additive inverse of plus 2? It's minus 2. You subtract 2 this side, then you do the same thing on the right hand side. So it's like we take the 2, becomes x minus 2. 3y is now isolated. We applied the additive inverse. Then 3y, the relationship of 3 and y is one of multiplication. So what do we do to the 3? We divide by 3. But what we do on one side, we do to everyone. Okay, so I divide x by 3, I divide negative 2 by 3. I can just write it all over 3. Thank you so much, Anyi, for the rows. Thank you. Then what do we have on the y? 3 divided by 3 is 1. That leaves us with 1y, but obviously y is the subject. On the other side, we have x minus 2 over 3. So imagine that this is my pen, currently facing like that. I take my pen, I just simply twist it around like that. So this y, I simply do that, guys. The twisting around. This is still the same thing. Y is equal to that. Still, y is equal to the same thing that I had. It's just that y is on the left-hand side, just for the purpose of subject of the equation. Then the grand finale. What did we say? If the function is written in the form of that, we rewrite in the form of that, and then we final answer for the inverse written in the form. So let's get into the groove. We had the inverse that they wanted us to find. So now y is going to be the inverse equal to x minus 2 over 3. That is fine, guys, as a finale. I know some people, they want to rather have it like this. Remember, this and that is the same thing. Or some people, that are very much OCD want to have the answer in this way. 1, 2, 3, these all mean the same thing. All right, all mean the same thing. They are all meaning the same thing. Okay, so any questions, guys? Any questions at all? So we've just taken a linear function, we've written it into what? We've written it into our inverse function. Okay. Any questions at all? 12s of 12. This is the first few things you need to know how to do well. You need to know how to determine the inverse of a function by actually applying the steps that I have just explained to you. So this one is specifically for a linear what? Function. We said most a linear function is 1-to-1. So of course, here is the inverse of that function. Okay. Followed the steps to the T. Okay. Right, let's move on. If you guys are fine and if you guys are okay. All right. Just to again recap, we had f of x is equal to 3x plus 2. We expressed it in terms of y and x by making sure that our functional notation is written now in algebraic y and x notation. After doing so, we do the dummy, and the maths is a game host of the hair. We swap the weave with the human hair, at least the African human hair, if you want to call it that. Let me not say, because yeah, weave, I guess, is still, yeah, sure guys, you get the point. Then we make y the what? The subject. After swapping, you must swap first. Please guys, don't forget to swap. Then you make y the subject, meaning you isolate y, take everything, plus 2, transpose x minus 2. 3y is isolated. 3 times y, you use the multiplicative inverse. You divide by 3. What you do on one side, you do on the other side. You also divide by 3 here. You get y is equal to x minus 2 over 3. Y is the subject. Then obviously you just make sure that that y is on the left, just so that we can have that sort of like flow in order. And then of course, the inverse of the function, you write it back in the functional notation of the inverse, so that your answer reflects that writing. All right. Sometimes guys, depending on the form in which they want the answer in, sometimes they will say write it in that form. Sometimes they may ask you to write it in that form. So you must always check what form do they want you in that particular question to be expressing your final answer in. Okay, so sometimes we may have to just leave it as y is equal to, depending on whether they want the final answer to be in that form. Or we may then obviously finish off and write in the functional inverse form. So it's functional notation inverse form. So always check what form do they want the final answer in. Let's move on. Let's look at the next one. So if you look at the previous question, they had said the inverse of f, not using words, but in algebraic sort of like language. They said they want the inverse if f of x is equal to 3x plus 2. No words, simply algebraic. You need to be able to interpret algebraic language so that you can know what they are asking in the question. So I have explained to you that this minus 1 and the f means the inverse. What is the inverse of f if the function f of x is equal to 3x plus 2? So you know what you ought to do because of that symbol. Inverse of f, this means the inverse. And you know what they want when they are asking you for the inverse. Thank you for the Jenny Pass. Okay, let's look at example 2. Now they want the, okay, so now we're looking at the parabola equation. The equation of the inverse of y is equal to 3x squared. Okay, for now guys, let's just focus on the equation, and the sketch and all of that will focus later on. I just want us to get the flow of how to find the equation of the inverse first. So what is the equation of the inverse of y is equal to 3x squared? This time round guys, we have a parabola. Y is equal to 3x squared. So method still the same. How so? First step, we need to make sure that the subject is y. So this is already y because this function was not written in functional notation. So we have it easy here. Y is equal to 3x squared. Then what follows guys after writing? Hopefully you guys are doing that. Maybe you have already written down, you are already have arrived at the answer. Maybe some of you know exactly what needs to be done. I Clap my hands for you. Good job. Okay. Maybe and it's amazing because you guys are amazing. Yeah, you winner, pressure. Okay, y is equal to 3x squared. So first step, yes, make sure we write the subject as y. If it was in functional notation, we would change the functional notation to variable form. Y is equal to. Second step, we swap Tumi's hair for my hair. So x is equal to 3y squared. Okay. Next step after swapping, make y the subject of the formula. So in this case, who is actually surrounding the y so that it is supposed to be isolated? There's a 3 that's multiplied. There's an exponent. So the priority first should be on the coefficient of 3. The exponent later. So let's coefficient 3 times. So what do? We use the inverse of multiplication, which is division. We divide by what? The coefficient, which is 3. But what we do on one side, we do where? On the other. So then what do we have? Which is equal to what? Okay, it's coming along very nicely, right? Coming along very nicely. Coming along very nicely. Coming along very nicely. Coming along very nicely. Okay, then remember guys, this is a square. We need to get rid of it. So the square, the inverse of square is square root, guys. Inverse of square is square root. But remember, if you do it on one side of the equation, you must do it on the other. And please take note of the following: plus, minus. I repeat, plus, minus. Plus, minus. When you take the square root in a equation, on the other side, plus, minus. Yo. How many houses have been sold? How many relationships have ended? How many marriages have broken? How many kids have gone to bed without food? Because someone made a silly mistake. Someone did not put plus minus. Someone omitted this thing. Take it in, guys, for a moment. In a equation, if you take the square root on either side, on the other side, plus minus needs to feature. That's so random, but it is so powerful. Random and powerful. How many lives, how many NSFAS loans were not fully paid and kids had to go back home halfway through their studies because they have a debt that they cannot pay? These are real issues, guys. I'll tell you this, grade 11s. You mean grade 12s. You must really work this year, guys. You see, you can't be depending on a bursary scheme. I'm sorry, on the NSFAS loan. It's failing our people. You need a bursary, full scale one that you know will pay for everything. If you are not a trust fund baby, if you are not a trust fund baby and your parents have actually been saving money for the past 19 years of your existence, 18 or 17, whatever it is, however old you are, and you have all the money that you need to study and change courses whenever you want, you know. So our situations are a bit different. Anyways, sorry for that moment, very important moment. it makes me appreciate those people that are sacrificing even now and are actually starting early, because it means they want to be ahead of the game. Your challenge, though, is to be consistent and not to be complacent the minute schools restart and think that, oh, I'm ahead, I'm good. No. Don't do that. Don't fall into the trap of complacence. So y is equal to the square root of plus minus plus minus the square root of x over 3. That is y. Then we can conclude and say is equal to plus minus x over 3. But guys, let me tell you this, okay, that this is the equation, right, that we get from I'm writing the equation of the parabola as an inverse. But I wish to let you know that this particular equation, if we were to sketch this particular graph, it would actually be not a function, because when we do the vertical line test, we would see that this is actually a one-to-many function. We are going to get into the details, but not today, of basically what it means, guys, when we have a function, when we have an equation such as this. Okay. No, Presh, we remember, Presh, I said to you, okay, when we were looking at this, if the function is written in the form f of x is equal to, we rewrite in the form y is equal to, and then the final answer for the inverse is written in the form of that. So I'm just trying to be consistent in being able to say that the finale answer obviously is the inverse. Okay, so yeah, let us, the inverse. Okay, of course this question was not really specific as to what form they wanted the answer in, just as the equation of the inverse of y is equal to 3x squared. They just want the equation. So if we write this as our final answer, there was no clause saying we must write the answer as y is equal to or the inverse of f with the functional notation is equal to. So if we do this, we are not wrong. If you wrote y is equal to plus minus x over 3 as your final answer, you are also not wrong. Okay, because they did not stipulate the form in which they wanted. They didn't say make y, like leave it as y the subject, or say the inverse of f. Okay, so it's fine if you leave it like this because there was no specifics. Okay, so let's continue though. All right, but like I said, we will get into sort of like the semantics here about parabola. Okay, the parabolas, the inverse of a parabola, and basically other things attached to it. For now, I'm just trying to get us into the flow and the groove of being able to express a function as a inverse in equation form. That's basically what I'm focusing on at the moment. We are going to look at other details and other things, but for now, the goal is just the inverse equation. That's all, right? So we've looked at a linear function. We've looked at parabola. Now we are going to look at exponential. Please take note of exponential and the following things that I will be saying. Okay? Please share these notes on your TikTok page. Okay, Annie, I will do that when I'm done. Exponents and logarithms. Hopefully I don't forget. I tend to forget. Exponents and logarithms. So exponents, in other words, exponents and logs. So now in grade 12, guys, exponents and logs, we know that the inverse of an exponential is your log or your logarithm. Okay, so logs were designed to solve for unknown exponents. And I'll tell you this, guys, logs specifically, they help us a lot, okay, Yes, Tennessee, definitely. 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 Yes. Are we asked to change the inverse function back to function notation? Yes, we can be asked to change the inverse function. You can be given a inverse, all right? And then they ask you to change it back. I mean, you do the same thing, all right? If you're asked to change it back, you do the same process, you know? Obviously, you are going to express this, you know, as y is equal to. Then after expressing this as y is equal to, what do? You're going to swap x here, y there, and then you make y the subject. That's it. All right. You're simply doing the same thing. All right. Doing the same thing. Anyways, let's look at logs. Logs or logarithms were designed to solve for unknown exponents. So let's look at an example. If we have, no, not here. Cubic functions in term 1 are not done. You do cubic functions together with calculus, okay? So cubic functions, not cubical functions, cubic, C-U-B-I-C. Cubic functions are done in term 2 when you do calculus. So when we do calculus, we look at cubic functions. Remember, there are also trig functions, but when we look at inverse graphs, we are specifically focusing on linear, parabola, and the exponential. That is our main focus. We don't even look at hyperbola. We look specifically at linear, parabola, and exponential. Okay, so the focus will be on those three here for this particular topic of inverse. Okay, so hang tight, guys, hang tight. Yes, there's a lot, but other things will come as we go along. Okay, so allow me, guys, to just do the things relevant for now. When the time comes for other things, please, we will open your eyes and your ears very wide so that you can accommodate those things. But let's stick to what we are on at the moment, please. Let's not lose sight of this first, because if we have our hearts too open so that we even miss what is happening now, hey, it's a problem. The present is now. Live in it, please, guys. The future is ahead. We'll prepare for it. The past is behind. We just need to learn from that. Okay, so logs were designed to solve for unknown exponents. So if 2 to the power a is equal to 7, what do we say, guys? A log form of 2 to the power a is equal to 7 is the following. This guy, which is the exponent, becomes the subject. 2 becomes the base. It is currently the base. Okay, 2 becomes the base of log. And then that 7 is placed next to log. So we have a, which is the subject, 2, which becomes the base of log. So this is log 7 base 2. This base 2 for this a is now the base for the log. Okay, so a is equal to log 7 base 2. This is a rule you need to know. Okay, a rule that you need to know. Sis P, send me a message on the side, please, if you want to communicate about that. I'll talk to you on the side. It's just that I'm busy with the lesson. I don't want the recording to have other information, especially pertaining to that. Okay, send me a DM, please. I'd appreciate that. So if 2 to the power a is equal to 7, then this becomes the subject, 2 becomes the base, 7 becomes the number that we say is next to log. So it's log 7 base 2. Please, guys, subject, base, next to log. 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 If, then this, please, guys. All right. 2. If x is equal to a to the power y. Do you see this again? This is general now. Subject, there it is. Base, there's the base. That is the number next to log, or the variable next to log. Subject, base, next to log. So you see, generally speaking, this is the rule. If x is equal to a to the power y, then y, subject, base, next to log. Subject base next to log, 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 subject base next to log. You know what I mean? And vice versa. If you have log, then obviously what is this? This is the base. What is this? On the other side of the equation, what is that? The exponent. Okay, so this is basically this here, the rule. Kalo Hatsu. And I don't know Kalo. Ah, my goodness, my golly gosh me. And if you want to convert log to exponent, okay, I usually say to my learners, if you have the log there, a goes and kicks the x, the base goes and kicks x, carries x as an exponent. So all of a sudden you have a to the power x. So this base goes and kicks the x and carries it as an exponent. So this a displaces x and x gets carried. Who gets left behind? Y. Then log disappears. I repeat, a kicks x, x is carried by a, and then y is left behind. Log disappears. You know? Yeah. It's like the Premier Log, right? The Premier Log at the moment, you must say, I think Orlando Pirates is doing the things. People are like Pagajuju all the way, you know. So the player kicks the ball, all right? Then the log disappears. Oh my soul. Y becomes the subject. A becomes the base. Obviously, it was the base. Kicks the x. X is carried, and y becomes the subject. Okay, so basically, that's why we say y is equal to a to the power x. But I mean, you know, the sort of like the reverse process. So guys, we are going to look at some examples how to determine the equation of the inverse if we are given exponential form. Here it is, the exponential form. So let's just take it one step at a time and familiarize ourselves with the law of log. Okay, if we are not used to it, it will get some getting used to, but I think the more we do of these things, slowly but surely we'll get there. When don't worry, don't panic. These things, they can be arranged. So first step, functional notation f of x. Functional notation f of x. So what do we do to f of x, guys? Come on, tell me. You know what we need to do. First step, as we always know what we ought to do. F of x is functional notation. Does it remain functional notation? Thank you, Sibulele Williams. Boo, 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 boo. Da Williams. Yeah. Y is equal to 7 to the power x. Change it to y, precious. Indeed, we've changed it to y. Step number 1 has been successfully done. Okay. Step number 2. What do we do, guys? Step number 2. Come on, you tell me. Step number 2, which is a simple step that we should all know by now. Come out, wherever you are. Ma'ewu. Amen, Ma'ewu. Ma'ewu, thank you. Determine the equation of the inverse of f of x is equal to 7 to the power x. My presh. There it is. F of x is equal to 7 to the power x. Determine the equation of the inverse of. Okay, that's just the first one. Okay, thank you, Ma'ewu. We swap. Okay, to me's here for mine, right? Yeah, we explain these things. We're swapping hair. In fact, that's the funny thing. You guys are you actually are swapping hair. You guys are doing exactly that nowadays, right? You are swapping hair. Someone in India is cutting their hair. They are going bald. And then they ship off their hair. It comes all the way to South Africa. And then you guys, you swap. You're swapping hair. You know, I didn't realize that that's the case, but it's actually true. It's legit. This swapping business is real. Okay, next. Okay, now we can apply the log law, right? We can apply the log law, all right? Okay, so what does this become? The exponent. The exponent becomes the subject. So we say y is equal to the x next to the log. The 7, which is the base for y, becomes the base for log. Amen. If we leave the subject as y, but of course, Tina, we know that since we were given f of x, the inverse of x is log x base 7. Helang. Sekhametse, helang. Oh, my soul. Then sings my soul. Helang. Ndati. Okay. That seemed nice enough. That seemed cute enough, right? That was cute. Don't you guys think? That was really cute. Okay. Here's yours. Come on. Do it. Let's see what you guys can do with this one. This is yours. Do it. F of x is equal to 5 to the power negative x. Let's go. Alright, I see there, log. I see you there, to me. I see you there. Okay, question is that 5 is that 5 see you there, Sibilele. I see you there, Tanase. Is it Sibilele, Mr. Williams? I see you there, Tanase. I see you there, to me, with your potential change there. See you, precious. Yeah, TikTok doesn't allow us to basify the 5, Doesn't allow us. Do you see, guys, that this 7 is written sort of like, there. Yeah, it's very important. We don't write it like next to 7. Of course, I understand you guys, it's because we can't basify. I get that. But I hope you guys understand, lest we fall into a misconception of thinking, oh, it's 7x. No. It's log x base. Just give me the base. You see? Okay. So I see your guys' response. So let's go. What we would do is we would y-fy first and foremost. We y-fy the f of x. We what? We y-fy. No, not y-fy. We y-fy the f of x. Then after y-fying the f of x, we play the Brazilian hair game. Okay, with South African hair. After we Brazilify the game, the hair, then what do we do after that? We logify. Okay, so let's remember when we logify, all right, what does this become? This negative y, it becomes the subject. The entire thing becomes the subject. Bring him down. Then what about the 5? It becomes the base for log. It was the base for to the power negative y. It was the base, numerical base, but now it becomes the base for the log. All right. Some essential understanding there that is very critical to have. Then what follows thereafter? So hopefully we see that base, guys. Thank you so much. Yes, yes, yes. We've got Miss Zim in the house. Tennessee. Yes, 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 yes. Yes, Malwetan. You've got it. Ndade. Ndade. But we can't leave the subject being what? Being negative. The subject must always be what, guys? The subject must always be. Hopefully we do know that the subject always needs to be positive. Even when we did literal equations in grade 10, we knew that when we basically deal with the subject needs to be positive. If the subject is not positive, there's crying to be had. So what we do, as you guys have probably seen and indicate, you divide both sides by what, so that is actually the case. Yeah, you guys are 100% correct. Yes, Bani Makele. Yes, Bani. Yeah. Man, I love what the bunny is saying there in the comment section. Okay, divide by -1. Yes, yes, yes. And then thereafter, the result of that, dividing by -1, gives us a beautiful, sweet, nice, romantic answer of that thing that you guys wrote so beautifully well. Yes, definitely. So therefore that becomes log x space 5. Yes, Tennessee. Yes, yes, yes. With that beautiful laugh of yours as well, resounding so beautifully in the air, right? But of course, since it was f of x, let us stay true and say log of the inverse of x, so that we are able to stay true. And that becomes our answer, which is so beautiful, and we are happy with the outcome. Okay, go. Let me give you another few minutes. You can do this one. Yes, guys, we are just routinizing so that we can become, so that these things become second nature, and we are not having serious problems with the logifying our exponential function. We want to logify very well. We want to inversify everything, and we want to be master pros, pro masters, master pros. Oh no, is that Johnny Finder? Johnny Finder, did you just join my live, Johnny? Oh my goodness, Johnny Finder, no ways. Bam 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 bam. Shem. What is it, Mayo? What's the Shem for now? What's happening there with Mayo? Shem, what now? Oh, that is so hilarious. I don't know why that is so funny, but that's funny. Why are we shaming there? Yeah. So Noabo, speak for yourself, my guy. So Noabo, speak for yourself. You are not ready enough for 2026. Chin, what is this nonsense? We are busy grinding, and when you come here and you're like, we ain't ready. Yeah, speak for yourself. Say, I am not ready for 2026. Do not put the we in the mix. Say I, don't say we. Speak for yourself, Sonwabo. Chin, coming here. The nerve of this guy. Right, we're not Dagalo. I think I nearly said something that I shouldn't have said, so I'll hold my horses. Dagalo. It just reminds me of another Xhosa word here. Yeah, that starts with DAK. That thing that Dagalo there. So he's saying things that showcase a certain state in Xhosa that is DAK. I'd rather not continue, but I don't appreciate when people come to the live and they just bam. Exactly, Dagalo. Exactly my point. Exactly my point. You see that word exactly. Yeah, it's better that you said it. This guy. 6,7. Where in the world does that 6? Thank you for your apology. Also, I apologize as well for insinuating or, but it's just that when please don't come and disturb our peace. Che, this guy, unbelievable. All right, let us proceed. P of x, obviously, y is equal to negative 4 to the power x. Step number 1. Step number 2, play the hair game. Brazilian weave for South African hair. X is equal to negative 4 to the power y. Brazilian weave for South African hair. Brazilian frontal. Or we can say I show speed for fish and nja. Which one? I show speed for fish and nja. Okay, x is equal to minus 4 to the power y. All right, now that we are here, guys. Now that we are here. Now that we are crazy here. Now that we are here. A base that is negative, I corner, it's not going to be nice. So what we are going to do, we're going to divide both sides by negative. All right, remember, this is negative 1 times 4 to the power y. So divide both sides by negative. I have negative x is equal to 4 to the power y. I do that strategically so I can avoid having a negative base. Okay, rather preferred that we don't have a negative base. So negative x is equal to 4 to the power y. What did I just do here? I divided both sides by negative 1. By so doing, this becomes positive 4 to the power y. This becomes negative x. Now I can go ahead and make y the subject of the formula. Okay. Y, remember guys, the exponent becomes the subject. The base is 4. Next to who? To log is negative x. And therefore, it is wonderful. P, the inverse of P, is equal to log base 4 negative x. Okay. Yeah. All right. Yeah. Okay. Can you feel me, my brothers and sisters? Yes, Bunny, you are very wrong. You are very wrong. When you write negative log 4, remember, it was 5. It is you like saying that is 4 to the power negative x, which is not true. Okay, does that make sense? Yes. So please, guys, please listen and listen very well. P to the power x is equal to negative 4 to the power x. Px becomes y is equal to negative 4 to the power x. Then after that, we swap Brazilian weave for South African hair, or fish and jar for iShow speed. All right. Then after that, the base is negative. We'd rather not have that. We divide both sides by negative 1. Base is now sweet and positive. Log can then be applied. So we now have y is equal to log. The base is positive 4. X is negative. There is the function of the inverse of p of x is equal to negative 4 to the power x. If we had said the answer is p inverse of p of x is equal to negative log base 4x, then it's like, this is the question, and it's not, guys. Okay, please. Yeah. Of course, Presh. Not all substitutions, my dear. Not all substitutions. Some substitutions, yes, maths error. Not all, my dear. Not all. Okay? Not all. Okay, I'm sure if you write the positive numbers, okay, if you substitute the positive numbers, it means that there are places where the function is not defined. Okay? So our x value will only have to be your negative values. That's where the function is defined. Remember, an exponential function has a what, guys? It has an asymptote. So if the initial function has a horizontal asymptote, then this one has a vertical asymptote. So because it's the inverse of the function. You're going to see, guys, when I start sketching. All right, I'm not yet going to do the sketching because, as I said to you, my focus right now is me trying to get you guys to know how to comfortably do the conversion of the function from its function to its inverse. I want you guys to become comfortable in manipulating the equation of the function to get its inverse. We are going to get to the point where we start sketching the function, the inverse, and all of those things. Then we are going to see what we have to see. Obviously, there are restrictions for this function. There are places where x cannot be, but there are places where x can be. All right. So very good observation, though, that substitution of certain x values leads to a condition that we refer to as what? As undefined. Because yes, the function has places where it does not exist. Because of what? Because of its domain. And furthermore, because of the asymptote that exists. So that's why. Okay. So I love that you guys are seeing those beautiful things. All right, let's now look at how to determine the equation of the inverse if we are given log this time round, not the exponential. From log to exponential, because we did exponential to log. Now let's check how we move from log to exponential. Right? So the method still remains the same, guys. Why do we say the method still remains the same? In that the first few steps are still the same as what we know we ought to do. So what do we mean by that? What is the first step we do? F of x is equal to log x base 5. Step number 1 of this that we do is that f of x, which is here, what do we need to do with f of x, guys? Yeah. Thank you, Malwetana. Yes, 5 is the base. Malwetana, Bontle, Tennessee, and Missing. Quasi. Yeah, quasi. 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 Oh, quasi. Okay. y is equal to log x base 5. We start there. Then after that, we do what, guys? Brazilian weave for legit hair. Fish and nja for I show speed. Swap. X is equal to log y. Next step, make y the subject. All right? Remember that thing I said, 5, what does he do? He kicks. X carries. Kick, carry. 5 kicks. So in the place of x now we have 5 and the x is carried. Who gets left behind? Y, as log disappears. So y is equal to 5 to the power x. 5 drop kicks, x carries. Y gets left behind. Subject, log disappears. So we are basically saying y is equal to 5 to the power x. In other words, the inverse, if we were to say, is equal to 5 to the power x. Not too shabby, hey Nige? Not too shabby at all. Was that too shabby? Not at all. I don't think it was too shabby at all, actually. Not too bad. Okay, not too bad, was it? Okay, here's one for you. I'll give you the last two. You guys do them. I am just going to watch as you guys do. Do. Actually, I think now I'm just going to chill and rest and behold. G of x is equal to log negative x, in the brackets it's negative x, base 3. G of x is equal to log negative x, the base is 3. And in number 1, we have quasi-Ngubane, and y is equal to negative 3 to the power x. And in second place, we have Tumi with y is equal to negative 3 to the power x. And then Tennessee with y is equal to negative 3 to the power x. First, second, and third place. Quasi in first place, Tumi in second place, Tennessee in third place. Okay. Could it be that we are all agreed? All right. Yeah, so I know you guys would write that final answer as G, the inverse of G. I understand that, but to make life easy, you guys went straight to the answer. So first step, y is equal to log. Second step, we swap. Third step, we step it up. Then y must become the subject. Divide by negative 1. And finally, so good job, girls. Good job. Precious, amazing, Tumi, amazing, Quasi, and Tennessee. Good job. Great job, boys and girls. All right. though I have a feeling you are all girls that did that phenomenal stuff in the comment section. Okay, here's another one, guys. This one is h of x is equal to negative log x base 2. Okay, Malutana. Kaloku, I'm saying those that answered. Malutana, in that singular instant, Kwazi is a boy. Okay, Kwazi, alright. Sorry. Boys and girls then. Boys and girls. Okay, boys and girls. No problem. Hope you don't die now. H of x is equal to negative log x base 2. H of x is equal to negative log x base 2. Whoa, that was fast, Presh. That was fast. Eh? Oh, look at you, hey? That was very fast, Miss Presh. Sure. And in first place, we have Presh with y is equal to 2 to the power negative x. Presh just wanted me to actually do the. And in second place, we have Tennessee with y is equal to 2 to the power negative x. When I Presh, you just wanted me to call you first, didn't you? And in second place, we have Tumi with y is equal to 2 to the power negative x. I just hope, guys, we're not just reproducing what we see above. What I would want is that you write what you are doing for real. Hopefully, pen and paper is out. People are really writing and answers are really flowing. This thing of people just reproducing answers that they see others writing. Boom, 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 boom. Okay, but I know I trust you guys. You're not doing such things. You guys are amazing people, I know for sure. For sure, for Presh, for Tumi, for Tennessee, for Presh, for Tennessee, for Tumi, and for Precious. Yeah, it had to be Precious and Presh, eh? You guys. All right. Okay, so then y is equal to, just to confirm what you guys have written, Brazilian weave divide both sides by negative. Make y the subject. I can see some people writing their answer like this. Which should also be very correct. Okay. I mean, of course, if you choose to write the answer as in positive exponents, trying to avoid negative exponents, simplified completely and fully, this would be 100% correct. No problem at all. Okay. Yeah. Because 2 to the power negative 1 outside to the power x is actually 1/2 to the power x if you write your final answer with positive exponents. Because of course there are moments when, of course, finally and fully positive exponents are what we usually say we ought to leave these answers as. Okay, right. Yeah, so we are reminding ourselves, guys, we are reminding each other, and as we remind each other, things are coming back, and as things are coming back, we are kind of like, okay, all right. Oh, I understand now. Lulimpepo, it's like the lights finally came on. All right, the lights finally came on. Guys, here is a feast of many good problems. All right, let me allow you guys now to just flex your muscles and to just do these now. All right, yeah, so let's devote 2 minutes per problem. The current time. Zingubani, what are you saying? Two to the power negative x is the same thing as 2 to the power negative 1 raised to the power x. So then 2 to the power negative 1 is a half, because 2 to the power negative 1 is written as 1 over 2, all raised to the power x. Okay. So the exponent x is for the entire 1 over 2. Are we together? 2 to the power negative x is 2 to the power negative 1 all to the power x. Because remember, guys, this is laws of exponents. Let's not forget these things, guys. Laws of exponents. A to the power m raised to the power n is a to the power m times n. So this negative 1 times the x when you separate. 2 to the power negative 1 is 1 over 2 raised to the power x. Okay. Okay. Yeah. Okay, I hope you understand. They are the same. That's what you should have said, Precious. 2 to the power negative x can be written as 1 over 2 to the power x. They are the same. Yeah, not they are inverses, they are the same. So please, guys, yeah. Okay, I'm busy with grade 11s with exponents. It seems like you guys will also need some exponential revision, it seems. Why does it feel like you are going to need it? Because it is when those exponents are solid that you won't have any misconception with the answer. Okay, it will be clear. 2 minutes, guys. 120 seconds. Find the inverse. I'm literally meaning 2 minutes, literally. 2239 and 2242. The answer must be done. F of x is equal to x plus 1. Do me. It's fine. We're going to wait for everybody else. So it's to me at number 1 for the first one. Yeah, that was quick. Oh, you were busy. Whilst we were busy arguing about that other exponent, when you had captured that problem in your head and you were busy. When you have a base with a negative exponent, the base concerned changes from the numerator to the denominator. If the base was in the numerator, so like 5 to the power negative n is the same thing as 5 over 1. So it's 5 to the power negative n over 1. So what happens is that the base changes position from the numerator to the denominator. Its exponent changes sign from negative to positive. Then a 1 is left over at the top. So the answer is 1 over 5 to the power n. We express negative exponents as positive exponents by applying this definition. So any base raised to the negative exponent, that base simply changes its position. So if that base was in the numerator, it changes its position to go to the denominator, and then the exponent that was negative changes to positive. If this base was in the denominator and it had a negative exponent, it would change its position from the denominator to the numerator. Okay. No, dear. Kwazingubani, it won't apply because the previous questions here, if you look at this here, okay, there was no negative exponent here, there was no negative exponent. Here we were given a exponent that is positive. Here it's fine, we were given a negative exponent. We are working with what we are given. It's fine, this is fine, that is fine. All right, here there's no negative exponent. So yeah, here it's fine, you work with what you are given. So we write y, we swap, then we write, and we get to the answer. So no, okay, but it's just specific to this, the final answer for h of x, because now we are simplifying the function so that it is expressed as a positive exponent. So yeah, we're working from there. Okay, unlike when we are given this and we are working towards getting that, this is the last step, this is the next step from the step, which is this. We are moving forward to get to the inverse. Okay, anyways, okay, so I hope yeah, you see now the 2 minutes kind of lapsed with me focusing on something else. Okay, I see you guys have written answers, very good. So let's just do it. Okay, so I hope we are all in agreement. The answer for this one here, right? Y is equal to x plus 1. We swap. X minus 1 is equal to y is equal to x minus 1. Remember, we were given the function as f of x, so we say inverse. So you guys are 100% correct. Let's do this one. Number 2. Want the inverse, guys. We are playing inverse game. Now I'm going to end this live with you guys doing all the problems. We are going to go until the very last one, and then that will be it for today. That will be that. Then we'll go on to the next thing tomorrow, guys. Just allow us to do these things one at a time. Okay? Yeah, not all at once, but we need to master the basics first, getting the equation right. Fundamental. Everything else, it flows from that. Okay, I see you guys. I see you. I see you. I see you guys. Oh, but you're killing me in the comment section. I love the fact that there's a fight of answers in the comment section and with how to express the answer. Y is equal to x squared. We want the inverse. Determine the equation of the inverse of each of the following functions. So we want the equation of the inverse for this function, the one that we are looking at right now. Okay, 2 minutes are coming up to end. 30 seconds left. Yes, precious. Yes. Okay. So now when we go over it, usual. X is equal to y squared. Okay, we don't have f of x, so I'm just going to leave the answer. In terms of y, take the square root on both sides. But remember, Moss, when you take the square root on both sides, y is equal to this plus minus the square root of x. Okay, let's move. Next one. H of x is equal to 3x, 2 minutes, 1046, 1048, times up, 1048. H of x is equal to 3x, equation of the inverse. Oh, do me, that was fast, my goodness. Sure, guys. Kimang. Okay, with just 30 seconds to go. Okay, time. Y is equal to 3x, x is equal to 3y, divide both sides by 3, x over 3 is equal to y. So that means say y is equal to x over 3. But of course, since we have h, the inverse of h is going to be x over 3. Remember, that is the same thing as 1 over 3, the x in line with the division sign if you want. So it's really up to you if you want to write it as x over 3 or you want to write it as 1 over 3. The x, please, is a coefficient of the variable x in the numerator. So you can write it in line with the divide sign. Not in the denominator, guys, but in line with the divide sign so that it carries the meaning. Okay. Next one. Let's go. The inverse of the function. Hi man, fresh. Yo, I call. You see, when you have people that quickly do problems like this, I'm sure you now kind of can internalize in your head why they would set a 150 mark paper and then they say that paper is 3 hours. Do you remember when you wrote your paper 1 and your paper 2, grade 11, end of the year for your final November exams? How many of you were able to finish paper 1? How many of you were able to finish paper 2? And if you didn't finish, do you still remember the topic that made you to struggle? Do you still remember what actually munched up your time? Because if you can remember well what actually did what, hopefully you will do something about that topic so that it does not ever do what it did to you. You know, because let me tell you this, some of you will complain, but I'll bring people to you that actually finished that paper. Okay, I'll bring people to you that finished that paper. Okay, they finished that paper, but when you didn't. Okay, and the question is why? So and then you have people, for instance, I give them a problem like this and they finish like literally in a blink of an eye. You ask yourself why. Yeah, so these are the things that, yeah, the sooner you can get down to some of these things. Yeah, question is, did you finish and then did you get the marks that are 95% and above or 90% and above for each paper? Because finishing is one thing. Sometimes you finish, but then the marks don't showcase themselves. We are talking about finishing and then the marks reflecting that your excellence definitely was had there simultaneous. Speed coupled with accuracy. That's what I'm talking about. Speed with accuracy, my guy. Speed with accuracy. All right. 80% plus. That's great. That's great. That's beautiful, Kwazi. Yeah, that's beautiful. But then, Kwazi, you'll have people that did not finish in the live lesson with you, but they got 90-something%. What is that? Yeah. So that means many errors were made. Or maybe your SBA mark for the year was not so great, Kwazi. What was happening there? Because 90 plus, maybe let's ask, was it 90 plus? Was it 80 plus? So 80 to 90, 80 to 89 by that 80 plus, not 90 plus. Yeah, trying to get the 90 plus guys going. Y is equal to minus x squared. Okay, so you guys know the routine. That is the routine. Okay, isn't that the routine? Yes, it is. All right. Then after we establish, of course, that is the routine for. Indeed, it is. No problem. Then what do we do, Kanene, after this? Guys, you should. I think 85% for final examination only. Oh, okay. All right. Yeah, you did well. Okay, I take that. Don't take that away from you. You did very well. Divide both sides, guys, by what here? Immediately we divide both sides by, thank you, precious, divide by -1. So we have negative x is equal to y squared. Very important. We do that first. Divide both sides by a negative. So important that is the case. After doing so, we can now take the square root. Both sides. For x, that is negative. Okay, so I wrote negative x is equal to y. When we conclude, y is equal to plus minus negative x. Okay, and of course, you would know there are values of x that will apply. There are values of x that will not apply. Because, of course, there's a restriction for this particular function's domain. So this is fine. Okay, this is fine. Kwazingubani is like x must be less than 0. Okay, all right. Remember here, all we are doing, we are trying to just work the form. All right, we are going to still get to problems where we obviously are going to look at the gymnastics and the specifics. For now, we are just wanting to see, can we convert? All right. Okay, so this is fine for the conversion, for the purpose of the conversion. Obviously, when we mingle it with functions and also other restrictions and interpretations of functions, then we are definitely going to incorporate everything else. For now, we are just trying to see if we can do the algebraic manipulation. Okay, yes, number 5. This one. 5. Ngwanesu. Who are these people? How can I say number 5 and then bam, guys are writing answers already? What is this? Oh, Kanye, you guys just see me every time I move. Oh, that's why. Or you were looking at the questions long time ago. It's like the answers are ready. So the minute I move to the next, people are like, boom. What is this? We are competing now, boys and girls. You guys are crazy. The insanity in the comment section is funny. Yes, Precious. That would be fine for the previous question, of course. But as I said, we are just that for now. We are just checking. Right. We are going to look at specifics that relate to your parabola. So we are still trying to just establish the skill of writing a graph in its inverse nature. That's all. Okay. We have top notch on the live. Sibulele Williams. We have top notch. Oh my soul. Oh my goodness, you guys. It's good. Competition is good, especially when it's healthy like this. Anyways, so y is equal to 3x minus 5, right? We write in terms of y and x. We swap. After swapping, we make y we make y the subject. So we have x plus 5. We take the minus 5 over. We isolate 3y. Taylor's version. It's holidays. It's holidays right now. I don't want to see maths now. Well, don't see it. Why did you even... You see, the thing is, Nina, if you actually spent the time and you wrote down the comment, it means you actually do want to see it. You just feel guilty that you have to see it now, right? If you didn't really want to see it, you would have just scrolled past through to the next video or to the next live that is entertaining to you. But you stayed and you wrote the comment, so you want to see it, okay? Or your body is doing things that your mind actually wants. Your body is failing you. It's failing. Your mind doesn't want, but your body says, hey, there's a fight there. I can sense a fight with Nina. X plus y is equal to 3y. You divide, guys, both sides by 3. So we have x plus 5 over 3 is equal to y. So you guys are 100% there. Hey, I love the people. I love the Landuga there. The inverse is equal to x plus 5 over 3. If you write it separately, we are fine. If you write it combined, that's fine. It can be 1 over 3x plus 5 over 3. That's also fine. Okay, so good job, guys. Really proud. Next one, number 6. Yeah. You guys are AI. Press AI, my girl. AI. So AI. Maleta, I was trying to get the thing. Presh is like quick on the typing as well. Presh, are you sure you're still human? Did no conversion? I'm starting to question some humans here on Earth, I'm telling you. Hayi, ngwanesu ki AI. My ew, not on my watch. It's going down. It's going down indeed. Malutana, come on, gents. Yeah, I think the gents are... Oh, I'm sorry to say, Lo Uti, you use log when the author Luna when you need to see a specialist, icon. The answer was marinating on her keyboard. I'm telling you now, I'm starting to believe that there's AI-ness also happening there, no doubt. Okay, anyways, y is equal to 4x squared. Obviously, that is already the equation. We swap y and x. And after swapping y and x, what do? We make y the subject. Divide both sides by the coefficient of y squared, which is 4. We take the square root on both sides. Becomes plus minus. Y is equal to plus minus the square root of x over 4. Those who are in the game of simplifying will do this so that they have the answer simplified as possible. So if we actually look at the answers that people have written, it seems like Tennessee actually was the one. That's if that line represents a square root for sure. Okay. If we're talking about a simplified, because remember with division, guys, you can apply the square root at the top, but at the bottom, that's a perfect square. So that means you can write it as the square root of x over, apply the square root in the denominator alone, it's 2. The square root of 4 is 2. So that means y is actually equal to plus minus. That is as simplified as possible. Okay. Yeah. But I don't think they would necessarily penalize you if you left it at this. But I mean, yeah, if we're talking about simplifying it as far as possible, the equation, then that makes perfect sense. Okay, let's move on. Next question. I give up. I give up so bad. Oh my goodness. You guys are killing me, man, in the comment section, really. Yo, Joe. The answers, man. The answers just come so fast. Kiso no karo na shem. We are just working, my guy, with making sure that with these questions, the only thing we are doing is we just want to get the method of converting from a function to its inverse. Right, that's all. We are not yet worried about whether that represents a function or not. We are just wanting to express this thing as an equation that reflects inverse for the graph. So please chill out. We're just working on that. Okay. This is just the first part. He's too late, my guy. Too late. Too late indeed. It's like after the bell. But that would probably also be a learner who's probably done grade 12. Some people that comment here, I can see when their comments reflect someone who's done grade 12 and they are just simply imposing whatever they know onto what is being done. But they don't have a sense of understanding as to where we are coming from and why we are doing what we are doing. So that's where they fail. Anyways, okay, I'm sure you guys can all agree that the answer is going to be h of x is equal to 3x plus 2. I'm not even going to bother and do it. Okay, I think for the purpose of fairness, I am now going to they are seeking validation. There's nothing wrong with doing that, but I hope that's not their character of their life. Because in life, you can't. You took personal, didn't you? No, my guy. I simply want to make sure that those who I'm busy with right now do not get entangled with sort of like your misconception of what we've been doing. We've been doing something from the beginning of the life. So, yeah. And I guess, yeah, I am taking it personally because this is my life. Yes, I'm taking it very personally. Chin, why am I saying I'm not? I'm taking it very personally. Very personal. Y is equal to negative x squared over 3. I'm taking it very personal. Very. High pressure, when you are AI, I'm convinced. You are AI lated, my girl. It's too much now. Too much. Chin. Ngwana. Hawema. Don't worry, I'm going to restore fairness just now. Alright, going to restore fairness just now. Check out the move that I pull next. Yeah. Going to restore fairness just now. Okay, I think guys we can agree that indeed the answer there is going to be y is equal to the square root of negative 3x as has been indicated, and then you're going to have plus minus outside the bracket, I mean the square root. Okay, I agree with you guys. I agree fully and completely. Just gonna change the dice and channel a bit here. Let's come here. I want to see this AI-ness. Inverse expressed as an inverse f of x is equal to 3 to the power x. So this is an exponent 3 to the power x. Oh my goodness. Gwazi is like, no, we need to take it for the guys. This can't be. It's been happening for too long. We need to change this thing. That's funny. Okay, so it's Gwazi at number 1. We've got pressure at number 2, Miss Sim number 3, Tennessee at number 4. Pressures, I think what you were answering even the previous question. Just couldn't let it go. Yeah, that's 100% correct, by the way. For the previous answer, 8 minus 2x over 3. That's correct. So you guys were seeing the questions. That's why you were answering them so quick, because you were seeing the next and the next question. Yeah, because he has definitely redeemed you guys. Finally, at long last. It's been a drought. It's been a drought. Y is equal to 3 to the power x. We swap, guys, and then we logify the answer. So logifying the answer, y is equal to log of x base 3. Next, g of x is equal to half to the power x. Enjoy it while it lasts. What kind of kids are these, man? I feel like I'm breeding animals here. Seems like Gwazi has got his A game on there. It's like when a man has become sick and tired of being sick and tired. Okay, so we got that one down, guys. G of x is equal to half to the power x. Okay, so guys, if we are working with exactly with what is there, we have there, simply going to write y is equal to half to the power x as we see it there, right? And then that half to the power x, of course, we can then say we swap so that we have y there. And then we can go straight to log y as the subject. The base is half. And then x is next to log. And ultimately, we can say the inverse of the function, okay, would be equal to log x with half as a base. Okay, and that's 100% fine. That's okay if we write it that way. You don't necessarily have to put the brackets there. You don't have to. Now, some of you may choose to change half to 2 to the power negative 1. Then you get 2 to the power negative x. And you work it from there. You will get a different answer. Well, not a different answer. You'll get the same answer, just expressed differently. Okay. Yeah. That's the whole point now. I'm trying to avoid showing the next question because the camera is very sure there's a deliberate mission to not show the next one because I don't like what's happening. I don't like what's happening. So it must be fair. Here's the next question. H of x is equal to 6 to the power negative x. And the war goes on and on. Okay, so now this time around we have Presh coming in at number 1, Zim coming in at number 2, Maeo coming at number 3, Precious Okay, so we are beginning to see various ways to approach questions, eh? We are beginning to see different ways to express the answer when it is in log, and I love that. Okay, so those that have log x base 6, 100% correct. Those that have log x base 1 over 6, 100% correct. Okay, yeah, 100% correct. Those are both correct, boys and girls. Very correct. Okay, very correct. So I love this. I love what I'm seeing because that means people are seeing the various ways in which one can maneuver, and it's good. Okay, so guys, working with what obviously I can see here without changing it to positive exponent, y is equal to 6 to the power negative x. We swap. And then make y the subject. Divide both sides by a negative. And then, of course, the inverse. No more competition from me, guys. Oh man, that's funny. Okay, but it was good, guys. Like, I actually liked the interaction there, because obviously now what it does, it actually pushes this notion and idea of the time. Okay, making sure we stick on time. So yes, of course, that's what you get if you keep 6 to the power negative x. But if you write it as 1 over 6 to the power x, obviously your answer will be log x base 1 over 6. I was getting started. All right, guys, I'm gonna allow us now to do like just 2 more. Okay, actually let's do this one. F of x is equal to minus 7 to the power negative x. Oh man. Causing Gubani at number 1, pressure number 2. That was so close though. Your guys' response was literally, I think, a split second apart. Literally a split second apart. The way those answers came in was insane. Oh my goodness, I'm not even keeping score. I'm not even keeping score, guys, at all. I'm not keeping score at all, but yo, that was fast. That was fast. Wow. All right, so f of x is equal to negative 7 to the power negative x. Yeah, so guys, good job there in the comment section. Definitely that answer 100% correct. Right, that log negative x base 7. Love it. You guys are good, man. I think You know, when you feel like a measure of satisfaction with what is happening, it's so nice. Okay, let's do this one. All right, as our next one. And then after this one, we'll do one last final one, and then that will be it, guys, for today. I am spent. I feel like the concept has been internalized. Okay, and that's what's important for me, that you guys are able to do it, not me showing myself that I am able to do it in front of you, but that you are able to do it. That's when I feel like we are winning. Precious at number 1, Precious at number 2. I think the guys just allowed the girls to do the things. Cheating? How? How is it cheating? And then Miss Zim just had to also showcase the fact that the answer can be expressed in positive exponent with 1/5 to the power x, which just solidifies it for the girls. Okay. I guess, but it's like Press said, the ladies own the streets, eh? This is lies. Single body, take the lost chief. It seems like you're going to be chiefed out, Mr. Kwaz. Okay. But yeah, well done. Okay. Yes. I think we can all agree that final answer h of x is equal to 1/5 to the power x if we're expressing the answer in positive exponents. But of course, if we are leaving it with that negative exponent, it's 5 to the power negative x. Okay. So Presh led us out there, and then Miss Sim actually ensured that there is that solidified finality in the answer. Okay. Izolo Ngiphoxile, I haven't healed. What in the world? Who is this? Ashley. Ngiphoxile, I haven't healed. What in the world? You would have to remind me. Me, I feel like I potter a lot of people. Is it pottered in the sense that you are waiting for me to have the live lesson, or was it pottered in the sense that there's a comment that basically emerged from my mouth based on something that happened? You're going to have to explain yourself in the comment section, please. That will be appreciated. But if it's because of not having the live, guys, sometimes it happens. Okay. Hopefully you guys will be able to show me a bit of mercy there. Chini, my daughter. Precious saying I am out this time round, and then bam. This human being is not for real. Guys, is Presh even human? Like, what is this? Cage Presh at number 1, Precious at number 2, Miss Zim at number 3, and Lwelimpepo at number 4. Hi guys, hi boo. The guys literally are like, they've stopped. I said something which you misunderstood was a wrong point. Really? I'm sorry. I'm sorry, Ashley. I'm sorry. It gets intense in here. It gets intense. And sometimes it's not really even because of maybe, what did you say? What did you say that I misunderstood? Would you care to remind me? Because literally, I'm not at that. I'm not in that same mind. That was yesterday, and most probably I was just being fired up by a lot of other things that were happening. Because it happens sometimes that in the live lessons, people do funny things and they comment funny things. So when I start going, it's like everybody else gets tainted. So I'm extremely sorry, Ash. Don't. Hopefully you can find it in your heart to forgive me. What did I say? What did I misunderstand? I'm sorry. I apologize. I'm not perfect. I'm sorry. My AO is like Precious is AI. I'm beginning to believe the same, my AO. I am beginning to believe the same. And here I was thinking, this is my, what in the world? Okay, g of x is equal to log. Yeah, guys, the answer there, indeed, right? I mean, even if we do it just mentally without having to do the whole calculator thing. It's the inverse of g of x, which is equal to negative 4 to the power x. Very evident if we do the whole swapping. All right, then I think this one can be the last one, guys. The grand finale. Who's taking the grand finale? I'm sorry, Ashley. Ashley, I'm sorry. I apologize. I'm very sorry. I'm very sorry. I'm not even going to excuse myself. Whatever I said to you, it was wrong. It was uncalled for, and I apologize. So hopefully from the bottom of my heart, you can receive my apology. I'm very sorry. I apologize. Very, very, very sorry. Very sorry. Sorry. Yo, I got a pressure and pressures at number 1 and 2. I'm scared ungaze ungiphinde if ngingaquli. Hayi man, Ashley. Now you are. Come on. No. You should not forgive me because you feel like I'll do it again. Come on. It should be genuinely because you find it in your heart to forgive me. Otherwise, I'm sorry. I'm really sorry. I think I was already riled up by many things that were happening in the comment section. Was it in which lesson was that? Actually, was it in the grade 12 lesson? No, I didn't teach. Didn't have a grade 12 lesson yesterday. I had grade 11s and grade 10s. So which lesson was it? Grade 11 or grade 10? Where I spit venom on you. Sure, I'm very sorry. Excuse me. Okay, it seems like there's different answers as well. Oh, we have people finalizing the answer. Oh, nice, good. Okay, negative half to the power x. Finalizing the answer, good. Oh, okay. Sorry, Ashley. What grade, Ashley? What grade was it? Grade 10, 11 that you were attending? Or did you maybe perhaps enter into a lesson that is another grade, but you are actually in another grade yourself? What grade are you in? Okay. So this one is quite interesting, guys. This one I didn't even have a subject for this. So, that's another thing that you should have noted, that I just had log, no subject of the equation, all right? But so that was supposed to have been there. You should have brought it to my attention. That's why we don't have the subject. So let's start it out. It's x, we know it's y is equal to log. We swap. Then after that, we kick. Right? Hey, that was 3 years ago. What? Hey, what's happening here? I'm lost now. Now you're losing me completely, Ash. Oh, I see. Oh man, I actually this is so funny for me. This is so hilarious. Okay, I get you. You were scrolling through. I wonder what did you say? I wonder what did you say? My goodness. I wonder. Divide both sides by negative. Guys, the answer is y is equal to negative half to the power x. Remember, this is the positive exponent. It can only be in this state. Okay. If we would write it as 2 to the power negative x, it just means we are writing it as a negative exponent. We want to leave it there in that situation. But I guess if you leave it as y to the power 2 to the power negative x, I mean, that's also, I mean, technically it's right, but as positive exponents, this is how it would be. Shella. Icon. Okay, guys, thank you so much. I think that was a fruitful session. Don't you guys think? I think that was really fruitful. Okay. What did we do today? We looked at the definition of what a function is, the formal definition. Okay. And how a one-to-one and a many-to-one is a function. And how a one-to-many is not a function. Then after that, we checked out and looked at how to write a function into its inverse equation. More specifically, guys, it was just at trying to look at how to express a function into its inverse equation. That's all we were doing here. So tomorrow, guys, when we have the live lesson, we can actually then go further into the specifics around a function that is a parabola. How do we express a parabola to actually reflect the definition of a function, meaning it is not going to be a one-to-many, but a many-to-one. So we are going to look at those, it's going to be a one-to-one. So we're going to look at those specifics, restricting the domain of a function for a parabola, sketching the function, seeing how it is, and then we are going to look at other things like reflecting in the x-axis, reflection in the y-axis, and reflecting in the line y is equal to x, and what that actually means in light of our inverse functions. And then we're going to look at interpretation type questions and take it from there. So please, guys, have a great and amazing night, glorious one to you guys, and let us keep that amazing, fun, competitive but progressive spirit alive. It's a very important one. Okay. Presh, the arrangements since schools are reopening. My girl, you guys are reopening school. Me, I'm not reopening school next week Monday. You guys are the ones that are reopening school. So I don't know what's going to be your guys' thing. See, the thing is, this year I'm not teaching grade 12 at my school, so that means I'm not reopening school. I was teaching grade 12 last year, so this year I'm not. So me is chilled. So at least for grade 12, that is, at my school. So that means I think I'm more than happy to continue having the live lessons until obviously schools officially reopen. So that means this evening time is fine for me for grade 12. We can just keep it at 9 onwards. Okay. Shem, I wish to be chilled too. What do you mean you wish to be chilled too? Who's this person? 19? What's happening with you? I wish to be chilled too. Yeah, so grade 12, I want to keep the evening time as 9 for you guys. 9 onwards. We'll see where it ends. Okay? 9 onwards. Try and have that consistency for 9 onwards. The evening time for grade 12. I prefer that time. But yeah, in evenings where there are things maybe that do interrupt, guys, you need to understand. Sometimes I can avail myself consistently. Sometimes it just happens that I can't. You're going back to school on Monday. Nice. Go back to school. That's nice. You are a learner. Or what? You are a teacher? The person who's saying I'm going back to school on Monday. Are you a teacher, my guy? Because he's saying, I wish I was chilled. Emo 19, what is this? Is this guy, are you a teacher 19? Nobody can equal me. Too cool for Mano 19. Or this guy Elena. Because the way he's saying, I wish I was chilled too. It's as though he's speaking as an age. You're a student. Oh, okay. No, man, don't be chilled. Chilling is not for grade 12s. Grade 12s don't know what chilling is. Okay. Guys, thank you so much. Thank you for the double taps. Thank you for the gifts as well. Thank you for 24k likes. We're ending the live at 24k likes, which is a phenomenal feat. Thank you so much. And thank you also for participating nicely during the live lesson. That was great. Yeah, you nearly made me want to cry because of emotions. Feeling very emotional right now. Okay, yeah. And I feel so bad for who's this person that was saying that I apparently railed on them. They were coming into my life for the first time, Ashley, because I'm realizing now that she probably received the road deal from me. Yeah, guys, it was worse today when I was doing the grade 10 and the grade 11 lesson. There was someone that came in and made a comment of, I was teaching factorization, and there's a method that I basically have suggested to the grade 10s and the 11s, grade 10 specifically, when it comes to trinomial factorization. So this person came and commented and was like, no, that's not, you're making it difficult for the learners the way that you are doing it. It's like that person unleashed the bear in me. I literally stopped dead in my tracks there, and I addressed that situation. And when I addressed it, it was not pretty. But nonetheless, it was more of like one of those things where I was like, I'm glad that you brought this up. And I think it's not a mistake that you came to my life. You are meant to actually make that comment so that you can go and start TikTok live lessons yourself, and then you can teach the learners the way that things are supposed to be done. Yeah, so sometimes things happen. There's purpose why some things happen. Some of you come to my live, you are trolling, you are not here because you just want to, I don't know, look for gaps, look for loopholes, then comment, or you are trying to suss out what is this guy doing here? Why is people joining his live lesson? Why does he have so many followers? Why can't I do the same thing? Guys, just do what you need to do, man. Right? Start somewhere. If you want to start doing live lessons, start live lessons. If you want to make a difference and help learners, go ahead, do it. But don't do it at the expense of. Don't do it at my expense. Don't come here and make me feel like what I'm doing is not good enough. So that was hilarious, bro. Science genie, aren't they? So I'm guessing you are experiencing it as well when you're doing your live lessons, eh? You're the coaches, bro. I actually had it with that one person, and I just told them that, please, ma'am, go and start your own live lessons. When you do, all the people that are here, I have no problem with diverting them to you, as long as the kids that you will be teaching will be exposed to a method that is more suitable and more palatable to them, and it will make maths performance and success a reality. I don't mind, because like I said, I'm not here for clicks. I'm not here for fanfare, man. I'm literally here to try and make a difference in the smallest way that's possible, man. I'm really not here for, I don't know, man. I'm not here for clout. I'm here to literally make a difference. You guys don't have any idea how it feels. You see, for the past 2 years, I've been marking metric papers. My heart breaks, man. Literally, this time round, when I was marking maths papers for grade 12, I wanted to cry, man. Like, literally. Like, in fact, let me not say I wanted to cry. My heart was breaking. Literally breaking, man. Because it breaks my heart to see how many people actually don't do as well in mathematics. It kills me, man. It kills me. You have no idea. It breaks my heart like nobody's business. And like I every time I leave that marking center, the marking center is having marked various papers from different areas and regions in the province where I stay. I always make that resolve that, you know what, if I can make a little bit more of a difference and change even someone's level from maybe a level 6 that was 78% to a level 7 that is 85%, and if there can just be a minute transformation of something little that can change, of knowledge transferred, I'm willing to make, that little bit of a difference. I'm happy to make that little bit of a difference. So that's why I'm saying this is not for clout. This is me trying to make the bit of a difference. Because it saddens me, man. It saddens me. Guys, I'm not lying. If you mark a paper, let's say a paper 2 out of 150, and the learner gets 2 out of 150, how would that make you feel, man? Like literally, like, what is that? How can, for an entire year of being taught, can someone at the end of the year write a final exam and get 2? Guys, it's inhuman, man. It's not. It's ridiculous. It's ludicrous. All right. And now when I'm, like, for instance, teaching certain things here, I emphasize certain things. And when I am emphasizing those things, there are certain flashbacks I'm having of certain things that I've marked in those papers. And I'm like, I can't afford to not emphasize these things because these are basics that these kids need to know. Because when they write, they cannot be losing marks such as this and this and that. So the one thing I know is that all the learners that do come and join my live lessons, they have no idea that the heart behind what I'm doing does not really have to do with anything that has to do with numbers, followers that I have, people that join my live lesson, or clout, anything else. It has to do with the heart of wanting to make a difference in the lives of the learners with their performance. Because if maths performance is good, it means access, open doors, opportunities open. Because maths, guys, can't run away from this thing that mathematics is a crucial, critical subject for access to many STEM-oriented careers. So, yeah. And it's becoming more and more rare to have learners that are aspiring for a maths performance within this range. 95% to 100% in maths. This here, guys, I believe that when a learner has been properly taught and they have no gaps of knowledge, then this here is a performance range that is realistic. Yeah, and this is basically, for me, the sights that I'm setting myself in when I teach learners. I don't teach learners for the purpose of getting something less than this range. I don't. This is me. This is me. So anyways, we'll ramble the whole night, but please understand my heart, and that's why I go crazy. I blow a gasket when there are people here that seemingly just are commenting for the sake of commenting. Some people just want to get attention in my life. They can see, oh, there's 70-something people in this person's life. Let me throw something so that someone can see what I'm saying, and then maybe they'll come to me. I've seen people here come and they'll be like, someone will say, "Sir, can you please explain that thing?" And then someone will comment and be like, "No, you can come to me, you can inbox me, text me, I'll explain it to you." You know, even in my WhatsApp groups, I remember last year someone actually came into my WhatsApp group who, I guess, pretending as if they are a learner, and the next thing I saw, this person advertise something of classes that they had, and then they wanted to invite learners into their platform, and they wanted those learners to pay a certain amount of money and all of that stuff. And I was like, yeah, people are doing the things. People are doing anything for anything. Anyways, please, guys, the heart behind it is for you guys to excel. So yeah, let's take it one step at a time. Thank you so much again for joining. This guy can talk. Let me live the life. Good night. Have a great night, and please take care of yourselves. See you tomorrow. Same time, same place. Be there or be there. Maths is a game. Let's play to win. Let's play to win. Let's play to win. Sergio, yeah, there's a few people here. You can just inbox me. I'll send you the link. For if you are in grade 12, inbox me. Just inbox me here on TikTok. I'll send you the link. Okay. All right. Bye bye. Goodbye.